Hi everyone, today we're going over lesson 1.4, day 2. We're continuing to solve absolute value equations. So to remind you of what we did last time, we used a technique called ISS, which stood for isolate, separate, solve, to solve an absolute value equation. Now these equations had something in absolute values on one side and a constant on the other side. And so in order to evaluate both possibilities of the absolute value, we would break into two pieces. One, where it's the linear equivalent with everything as you see it, and C being the number that we had in the original equation. And then the second one where we used negative C, so the opposite of the value that we originally had with the absolute value. Because remember, the inside of an absolute value can either be positive or negative. It's a distance from zero. This time, we're going to talk about a little more complex version of this same thing. And so in this case, we could have an absolute value on one side and something with a variable instead of a constant. Could also be a second absolute value on the other side. So this is just one step up from what we did last time. So we are going to isolate our absolute value if possible. If we can't isolate it, we're going to identify one as our main one. So the one that is highlighted in turquoise will be our main one, even if we can't completely isolate absolute value on one side. The second step is going to still be to separate, but this time we're adding a D there. So separate and distribute, because now we may have more than one term on the right-hand side. And so the negative that we are used to applying for our second equation that we solve, our second linear equation, has to distribute to all terms on the right-hand side. There may not be just one term. And so we will then solve those absolute values. And then the last thing that we need to do, and we'll talk about this a little later in the lesson, is if you have variables on both sides. So in this case, we have an x over here and an x over here that may or may not be in absolute values, you should check for extraneous solutions. We spoke about those a little bit last time, but those are basically solutions that when plugged into the original equation do not come out with a true statement.
Let's look at this first example where we have an absolute value on each side and variables on each side instead of just a constant on one of our sides. In this case, we will just identify one of our sides as our main side that we're going to solve for, and the other one will become our solution side that we will choose a negative and positive version of the solution. We will now separate into two pieces. We have the linear equation 2x plus 5 is equal to x, and we have the equation 2x plus 5 is equal to negative x. We need to solve each of these. I'll solve the first one by subtracting 2x from both sides, leaving me with 5 is equal to negative x, and then divide by a negative 1 to get rid of that negative, giving me 5, or x is equal to negative 5. The other equation started out the same way, subtract 2x from both sides, leaving me with 5. This time it's negative x minus 2x, which is a negative 3x. We'll divide out the negative 3, leaving me with x is equal to negative 5/3. So writing this in set notation, as you will see it sometimes, this x is equal to negative 5 or negative 5/3. Our second example, we will go ahead and identify the left-hand side as our isolated absolute value. Notice the right-hand side has that extra 2 there, so it's going to be better for us to just go ahead and do that side without the 2 as our isolated absolute value, and then the right side, the 2 times the absolute value of 3x plus 1 will be our solution that we will do the positive and negative versions of. All right, so separating into two pieces, and I'm going to just draw a line here so that it's a little easier to tell which one I'm working on now. I'm going to have 4x minus 10 is equal to 2 times 3x plus 1. Notice that the absolute value bars have been substituted with parentheses, we cannot ignore the fact that that 2 is on the outside and needs to be distributed. Even though we've removed the absolute value bars, we still need a grouping symbol. All right, 4x minus 10 could also be equal to negative 2 times 3x plus 1. That's the negative version. So this is my positive version, and this is my negative version. I guess I didn't actually highlight that on the other one, so let's do that real quick. All right, so now we will solve each of these equations. The first thing I want to do is get rid of the parentheses by distributing the 2. Remember that that distributes to each term in parentheses, giving me 6x plus 2. And now I can start to move variables to one side, constants to the other. You can approach this a few ways. I'm choosing to go ahead and subtract negative 4 from both sides, leaving with negative 10 is equal to 2x plus 2. And then I can move the 2 over by subtracting it from both sides. Negative 12 is equal to 2x, or x is equal to negative 6. Let's go ahead and solve the other one. We'll start the same way by getting rid of the grouping symbols, the parentheses. Again, distributing to each term, both the negative that needs to be distributed and the original 2, leaves me with negative 6x minus 2. And now I need to move variables and constants around to group them on the sides. So I will move the negative 4x to the right, leaving me with negative 10 is equal to negative 10x minus 2. And then I'll add 2 to both sides to get rid of that. Negative 8 is equal to negative 10x, and divide by negative 10. This is going to give me x is equal to a positive 8 over 10, because the negatives on top and bottom will cancel, and this can simplify to 4 over 5. So my two solutions, my two x's, is the set of negative 6 and a positive 4 over 5.